Okay, so uh, let's try to answer this question here. We want to get the resultant vectors. Okay, when we say resultant vectors, it's the same thing as taking the sum of the vectors. Okay, uh, sometimes it's helpful to identify our different vectors as, saying this one here, I just gonna call this one A, and this is my vector B. Okay, so to get the sum of these two vectors here, remember that the sum or the resultant is just being drawn from the tail of your first vector towards, so draw a straight line. A straight line connecting between the tail of your first vector towards the tip of the last vector added. So the arrow is in that direction, okay? Not the other way around, because that would be a wrong representation of your resultant vector. So this is my resultant vector R, okay? So in this particular case, if you can see, this is already in right angled triangle here. So to solve, the first thing that I'm going to do is solve for its magnitude. And remember that for the direction should be based, remember, it should be based from your tail, okay? So the direction of your resultant vector R should not be placed here. It should be based from the tail of your resultant vector. So I can use this angle here, or maybe I'll just use this angle here as my theta. Okay. So how would you solve for magnitude? Magnitude of R. Okay. So if you can see here, vector A and vector B are completely, they're just 90 degrees with each other. So is it not that the longest side, the magnitude of R, which can be represented by this symbol here? If you can see this symbol, it only means that you're getting the magnitude of R. If you can see it there, that's the longest side of your right angle triangle. And if you use the Pythagorean theorem, like the longest side or the magnitude of R is just the square root of 10 squared plus 12 squared. So just the two sides. Again, you can do that because this is just 90 degrees. Anyway, again, that is just a right angled triangle. So you'll get an answer of magnitude of R equivalent to 16 kilometers. However, remember that if you are solving for a vector quantity, you need not only to solve the magnitude but also its direction. So you need to solve for theta. Solve theta. So that particular angle there. So based on that particular angle, this becomes my adjacent side, and this is my opposite side. Okay. So even though I have more options here because I've already identified the three sides of my right angled triangle, but if I'm gonna base it from the given, I have opposite and the adjacent side. So that is TOA, or tangent function. So tangent theta is equivalent to opposite side of, again, it's opposite over adjacent. So tangent theta is equal to 12 over 10. By the way, when you get in solving for the angle theta, if you can remember, tangent theta, the ratio of tangent theta is 12 over 10. But if you're going to solve for theta, you take the inverse of that. So if you can see, just take the absolute value here. That means that if this is negative for some, yeah, remember that the x and the y component here can be positive or negative, but just take the positive value of that. Tangent inverse is around 50 degrees. So that means that this particular angle here is 50 degrees. So finally, you should write your answer or the resultant as the magnitude of 16 kilometers and the direction of 50 degrees. Well, this is based on north. And again, it is in the first quadrant. Again, the placement of your arrow is going up. So again, this would be your basis. That's first quadrant. So that is north and east. But since the reference is north, the direction should be east of north. Okay? So the final answer is 16 kilometers, 50 degrees east of north. Okay? Or again, it's just the same thing. I know that if I'm gonna get the angle on the other side, this is just 40 degrees. So therefore, I can also write it as 16 kilometers, 40 degrees north of east. So both are pertaining to the same direction, okay? So 50 degrees east of north or 40 degrees north of east. Any question with this one here? There's none. So we proceed with the second one. With the second one, you have this vector here, 2.5 meters per second, 30 degrees north of east, and then you have 1.5 meters per second north. Okay, so if I gonna draw out my resultant vector, the resultant vector is just a line connecting. So just a straight line connecting the tail of my first vector. Okay. Oh man. Okay. So just a vector that connects these two vectors here. So this would be your resultant vector here. Okay. So graphically, you can represent it that way. However, same thing as before. I can assign that this is my A vector A here, and this is my vector B. Okay, but I need to take note that my vector A would have both X and Y component. So this is no longer as simple as the first example here, because the first example gives you a right angled triangle. But this one here, obviously, that's no longer a right angled triangle. Okay. So uh, what you're gonna do here is you're gonna employ the uh, breaking down each vector to its components. So again, that's the first thing that I'm gonna do. Break down each component to x and y. Break each vector, each vector, each vector to x and y components. Okay, so that's the first thing that you need to do. So that means that for vector A, I know that it has x and y component. So if you can see here, my vector A has, this is my x component, and this is my y component. So 30 degrees is here, that is 30 degrees. So if I gonna solve for x component, that would be 2.5 cosine of 30 degrees. And that should give me an answer of around 2.17 meters per second. And this is positive because the direction is to the right. For the y component, it's 2.5 cosine, it's not cosine but sine of 30 degrees. And that should give me positive 1.25. Okay, so now if I gonna do my b, so breaking down b into its x and y component, well, if you can see, vector b is just lying in the y-axis, and any vector that is lying on an axis, you should expect that one of its component is 0. So in this case, this particular vector b is just lying on the y-axis here. So automatically the x value is 0. And the y value is just positive 1.5 meters per second. Okay. So the second step is, okay, the summation of all x and summation of all the y's. So each component. So for x, you have 2.17 plus 0. So that gives you an answer of just 2.17 meters per second. Okay? And for the value of y, you get 1.25 plus 1.5. So that gives you 2.75 meters per second. So if you can see here, actually this becomes your x and the y component of the resultant. This becomes the components of the resultant. So that means that this whole thing here is just 2.75, and this one here is 2.17. Okay, so after getting the total, you use the Pythagorean theorem to get the magnitude of the resultant. So you just take the square root of 2.17, or just the summation of x squared, plus 2 point, again, I'll just gonna write for your reference. So the magnitude of your r will be the square root of summation of all the x squared plus summation of all the y squared, or that's the square root of 2.17 squared plus 2.75 squared. And if you're gonna do that, you'll get an answer of 3.5 meters per second. So that's the magnitude of my resultant. So the last step, or at least second to the last step, would be solving for theta. So you should decide, where is your theta here? Well, if I'm gonna set my theta would be here, okay, if that's my theta, so I can use tangent. Tangent theta opposite over the adjacent side. So this becomes the opposite. This becomes the adjacent side. So what is that opposite side? Well, so tangent theta is the opposite side is just 2.75 all over ax in this case, which is equivalent to summation of all x, that's 2.17, or theta is equal to the tangent inverse of 2.75 over 2.17, which should give you a value of around 52 degrees. So finally, you try to write your answer as the magnitude of 3 point, so resultant in vector form is now 3.5 meters per second, and 52 degrees, that's in the first quadrant, and the reference is east, so that would be north of east. So the final answer is this one here. It might be long, but again, you can employ the same strategy in solving even 100 vectors added. So any questions? Any questions? If there's none, we can proceed with example number 4. Okay. Here, to fly from Vancouver to Toronto, a plane travels at 11 degrees south of east at 450 kilometers per hour. How far east would the plane travel in 2 hours? How far south would the plane travel in 2 hours? And let us see, if the plane pushes the plane's velocity vector north, how would that affect your previous answers? So let's take first the uh, first question. So we're given that the plane is moving at this velocity and the direction is 11 degrees south of east. So to represent that one, that would be in the fourth quadrant. Okay, so 11 degrees is south of east, so that would be the east direction. 11 degrees is there. And the magnitude of this one is 450 kilometers per hour. Okay. So for letter A, we're just being asked to solve how far east would a plane travel in 2 hours. So we're given the time after 2t is equal to 2.0 hours. T here is 2.0 hours. And there's one thing that you need to remember if we're talking about vectors. Vectors that are perpendicular. When you say perpendicular, they are 90 degrees apart. Okay. Are independent. So what's the meaning of that one? That means that the distance going east is only affected by its speed or velocity along east. Okay. So therefore the distance traveled east is just dependent on, so general formula of velocity is delta dx over t. So if you can see here, velocity along x, so that means that you're just talking about the displacement along x. Okay, so if we want to solve for how far, so we're just going to solve for delta dx, vx times t. So therefore, we don't need to use 450 kilometers here, because if you can see in my letter A, I need to use the x component of the velocity. So Vx is just given by this component here. This is my Vx. And that is equivalent to 450 times cosine of 11 degrees. And that gives you 442 kilometers per hour east. And just the y component is this one here. This is my Vy. That would be 450 multiplied by sine of 11 degrees. So if you're going to do that, this is 85.9 kilometers per hour south. Okay, instead of using negative sign there or positive sign, I formally use the different direction, south and east. So if you can see here, my Vx is just this magnitude here. So therefore, that would be 442 multiplied by 2. So that gives you around 880 kilometers east. So it would travel 880 kilometers east. And then for letter B, again, south. South is your y component. Again, south is in the y component. So therefore, you'll be talking about the displacement along the y. So delta dy is equal to Vy times t. So Vy is given by the value of 85.9 kilometers. So that would be 85.9 multiplied by 2. It's around 170 kilometers and direction is south. Okay. So for letter C, if the wind pushes the plane's velocity vector north, how would that affect your previous answers? So that means that, do you think this is affected and also this one affected, or neither of the two is affected, or only one is affected? So remember that the wind is maybe going north. Yep, velocity vector going north. So it asks you, does it affect your travel going east and the travel going south? Anyone? Anyone?
You travel going south.
Okay. Only south. How about
Um,
the?
I
How
mean,
about
I'm
the?
just guessing. So,
Okay. So okay. Other anyone? Are there anyone? Any idea? So according to William, it's only the south travels that is being affected. So that means that this displacement along east would be the same. So it's not affected. Or do you share the same sentiment with William or the others? Well, yeah, actually William is correct. So no effect on eastern travels. So even though how hard it's blowing north, the displacement of the airplane is still the same. Well, it will definitely affect though the southern travels. And this particular concept though is relatively important when we talk about projectile motion, because it's a motion wherein it's a combination of x and y motion, but those two motions are independent from each other. Okay, so they're perpendicular 90 degrees, are independent. So that means that the y component of the velocity only affects all the y component, like the displacement or the velocity, but the x component only affects the x component also, if you're talking about the velocity or its displacement. Okay, so are there any question with example number 4?
Yeah, sir. For the answer, like the question A, you
Mm-hmm.
just write the 880, but I don't know, it is about a significant or something.
Yeah, just two significant digits, like the final answer, because you have there 2.0.
Oh, I see. It's
Yeah.
two
So yeah,
zero. Okay.
yeah. So this is just our basis. Regardless, maybe in the intermediate steps, if you have somehow rounded off, just make sure though that the final answer would be based on the number of significant figures of our given. Like
Okay,
for
thank you.
example, yeah, yeah, for example here, the given is 11 degrees. This is a measured value, so therefore that would count. You have 2. 450 has 2 also, as well as 2.0 here has also 2. So the final answer should be 2. I wouldn't mind if you have somehow rounded off certain numbers here. Supposedly Vx and Vy, you don't have to necessarily express them in two significant digits because these are not your final answer. The final answer here is your essentially the displacement along x and the displacement along y, uh, because that's the main question. So maybe in our case, let's just try to decide, because anyway, most of the things here, this is now formula based. So most formulas are in multiplication and division. So whatever is the given, the least number of significant digits of the given, we just follow that one. So I wouldn't mind if you somehow, not necessarily for Vx and Vy here, if you round it off, I wouldn't mind if you just write as many decimal point. That is also fine. Because anyway, this is not, I know that cosine 11, sometimes sine 11, gives you several decimal places. Because commonly, we actually plug this one in to the expression of Vx in our expression for delta x here, so that we'll get the final answer as precisely as possible. Like for example here, we don't have to solve right away Vx as 442. We can actually plug in 450 cosine 11 times 2 in our main equation here of delta x. But sometimes that could be, again, long, and sometimes that's prone to mistakes. So I would accept you to just solve first the Vx and the Vy, and then plug it in the same thing as this one here. Would That would be fine. Any questions? Okay. For example number 5, I want you to try this one out. So I'm gonna give you maybe 15 minutes before I will discuss example number 5. Okay? So try to do this one independently. Uh, you can actually assign different letters, like what I did. You can call this one as your vector A. This is your vector B. This is your vector C. This is your vector D. So you have 4 vectors there, and you want to get the resultant vector. So kindly do example number 5, and then let's see what you got, and let's compare with my answer later on. So again, at 225, we're gonna go back to this particular example here. Okay, so do an independent work on example number 5.